So in this video, we're going to cover the nomenclature of alkanes. We're not going to have any substituents on these alkanes like halogens or nitro groups or anything like that. It's just all going to be carbon for this video. Carbon and hydrogen. So let's tackle this problem here first. Now, the first step that we need to take is to find the longest carbon chain. And there's no trick to it. You just need to number it out. And if you want to use different colored pens or pencils to help you figure that out, then that's what you use. What if I tried this way? 1, 2, 3, 4. Okay, well, in blue, I go up to 5. And in this green, I see I only go to 4. So that pathway is just not going to work. That's just too small because 5 is bigger than 4, right? So what if I did it this way? 1. Same. It ended up with 5, right? Okay. So what we found here is our longest carbon chain. And that's going to be 5, so that means that we have a name, a parent name of pentane. Like that. Now the next challenge that we need to accomplish or figure out is numbering that longest parent chain in the correct way, or better yet, in the correct direction. Okay, so the first issue, let's say we're going to use these dark blue numbers, okay? Do I number it from this side to that side, 1 through 5? Or do I number it in the opposite way? Like that. So you see, it's the same carbon chain. It's just, do we number it in this direction or in this direction? And we have to follow the rules. The rules tell us which way to do it. So if we look at these greenish yellow numbers, we are asking ourselves, at what point do we bump into a substituent? Well, we go carbon 1, 2, 3, and at carbon 3, I bump into a methyl substituent. And then a substituent at carbon 4, and then we just continue to carbon 5. So we bump into 2 substituents, which are these guys right here. That's not the best marker now, is it? That guy and that guy are substituents. And when we're numbering this with the yellowish green number here, we bump into the first substituent at carbon 3. But when we look at the blue numbers, do we see how we go 1, 2, we bump into a substituent at carbon 2. So the way that we number this is with the blue numbers, because we bump into our substituent, first substituent, that's the key, our first substituent at carbon 2. And so we can then also put up on the board here, what substituents do we have? We have a methyl, and we have another methyl. So I put that down. Now we've already correctly numbered the parent chain correctly, so now we need to differentiate which methyl is which. And we'll put this methyl at carbon 2 and this methyl at carbon 3. And now we just put this all together. Okay. Now when you have 2 substituents with the same name, in this particular case, you don't have to write it out twice. What you do is you go 2, 3 dash. So you see position 2, position 3, and what do we have at those positions? We have methyls. We have methyl groups. But how many methyl groups do we have? We have 2 of them. So So that would be a dimethyl to tell us that there's two. So in a roundabout way, I've gotten those two substituents written down first. And then, so that's check. I got that in my name. And then we just have to tack on the parent name. Pentane. So this molecule right here has a name of 2,3-dimethylpentane. Now you have to be very careful because an incorrect answer, okay? A very incorrect answer would be 3,4-dimethylpentane. Now, if you're not careful and you're like, look at this problem here and try to name it, and you just look at the answer choices, this one might seem very tempting because look at that. What is that saying? That's simply saying that the person who tried to name this molecule numbered it like that. So we have a 3-methyl and a 4-methyl. That's what they're thinking. But why is that wrong? Because we bump into the substituent at carbon 3. But when we number it in the blue numbers, we bump into it at carbon 2. So be very cautious of that. My advice, if you're given problems like this on the exam, and it asks you to name it, but it's a multiple choice answer or question, don't look at the answers. Look at this. You come up with the name, and then match what you came up with the answer choices. That's the best way to do it. Let's tackle this next one. Finding the longest carbon chain. So let's just do it without writing anything down. Let's just count. 1, 2, 3, 4, 5, 6. Could I go further? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. See, or I could start over here. 1, 2, 3, 4, 5, 6. Doesn't matter which pathway I've taken here, it's going to be 6 carbons. So the parent it's very squeaky. It's going to be hexane. So there's that first part. Now we need to number the longest, the longest parent, or not the longest parent, the longest carbon chain, which is the parent chain. We need to number it in the right direction. So what if I numbered it this way? 1, 2. Now in this particular case, I could have put the 6th carbon on this one, which I did, or that one, or that one. It's the same path. It's going to be the same length, okay? So in that numbering scheme there, I'm like, okay, is that right? And I go through the motion here of, okay, when do I bump into my substituent? I bump into it at carbon 2, and then 3, 4, 5. So that guy and that guy are the substituents. So in the green, I have substituents at carbon 2 and 5, 5. I have 2 substituents at carbon 5. So that's what I have going on with that numbering scheme. But what if I numbered it in the opposite direction? Let's see if I have a different color here. 1. Like that. Now, I bump into my first substituents at carbon 2. I'm looking at the pink numbers now. But now look at the difference here. I have 2 substituents at carbon 2. So I have a, and that's going dead. Not a day for markers. 2, 2, 1, 2, 3, 4, 5, and a 5 right there. So the first rule is you number the carbon chain in which you bump into the first substituent. Okay? And when I went with the green numbers, I bumped it at position 2. And when I went with pink numbers, I bumped it into position 2. So we have a tie. So how do we break that tie? Well, you want to give, if you have a tie in this particular situation, you want to give the lowest locate number to the position that's going to give the most substituents the lowest locate number. So you can see here, 225 is smaller than a 255. So we're going to number this alkane in the pink numbers from left to right. So if we redraw this here, like that, we'll number them. Like so. So we have our parent name. We've numbered it correctly now. Now we just have to find we name our substituents. What do we have here? There's a methyl there. There's a methyl there and a methyl there. Those are our substituents. And so I like to write it all down. It's just how I like to do it. And I have one at 5, 2, and 2. And we put this name together. We're like, all right, we have 3 substituents that are the same. So we don't need to write methyls out 3 separate times, right? We just need to do it once. So we just go, I don't want to cut this off here. 2, 2, 2, 2, 5, getting those numbers there. And we have methyl groups. How many methyl groups? We have 3 methyl groups, so that means we have to use the prefix trimethyl. And then we just have to tack on the parent name, hexane. We'll erase that. Like so. Hey, let's tackle that last one there. I take that back. Before we go to that last one, students may wonder, well, what if? And this is great if you're having this thought. You're having that what if question. Okay, what if I numbered it this way? 1, 2, 3, like that. And now that's my substituent. Does it matter? Well, name it and see if you come up with a different name. If you come up with a different name, then yes, it matters. But if you don't, then it doesn't matter. So look at this. If I use this molecule here now and go through that same process, watch what happens. I already know my parent name's hexane. And when I evaluate, I see a substituent at I have methyl groups. I have 3 of them. Right? Methyl and another methyl. And where are those methyl groups at? Carbon 2, carbon 2, carbon 5. Do you see how we're going to get the exact same name? Because it's a 225, 225. Same molecule. So it does not matter. So I could have even said, well, what if I numbered it over here? Carbon 1. And that's the substituent. Going to get the same exact molecule. Okay, tackling this one. Let's find the longest carbon chain here. What if I go 1, 2, 3, 4, 5, 6. Got to 6, okay? What if I go 1, 2, 3, 4, 5, 6? Okay. What if I try this pathway? 1, 2, 3, 4, 5. Okay, so that's shorter, so that's not a good one. Could I go this way? 1, 2, 3, 4, 5, 6. So I could have went this way. Got 6. Looks like every pathway that I'm trying here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I can't get anything larger than a 6. You can definitely get something smaller than a 6. 1, 2, 3, 4, 5. But that's not the point. The longest continuous chain. So that means our parent for this guy is going to be another hexane. So that's pretty messy now, so we can clean that. Let's redraw it here. So we know it's hexane. But now, how do we number it? In which direction and which pathway? Okay, so let's take a look at a couple here. What if I start here? 1, 2, 3, 4, 5, 6. So when I number it in that scheme in blue, when do I bump into my first substituent? 1, 2. That's my substituent. And that's my substituent. You see how that's coming off the parent chain? So I bump into my first substituent at carbon 3 in that numbering scheme. Right. Let's do another skeletal structure here. So it's just cleaner. Okay. What if I number it this way? 1, 2, 3, 4, 5, 6. Now, what are my substituents in this numbering scheme? There, there, and there. Oh, I also forgot. Nope. Oh, that's good. So in this numbering scheme right here, I have 3 substituents compared to only 2. Does that matter? Hopefully you're all saying, no, it doesn't. That's not found in the rules. The rule states that you want to find the longest continuous path, or the parent, and you number in such a way that the first substituent that you bump into. So if I number it this way, I get at a methyl at carbon 2, like that. So, okay, so compared to these two, this one wins, right? Well, always double check though. What if you numbered it in the opposite direction though? What if I did it this way? 1, that's the same color here. Let's see here. So what if I numbered it in the opposite direction? Always good idea to just double check that. In the green numbers here, 1, 2, 3. I bump into that ethyl at carbon 3. And if I do the same process for this guy, I bump into the substituent 1, 2, 3. So 3. So this one is a 3, 3, okay, and this one is a 2, 3, depending on how I number it. So this one wins out, okay? But then with respect to just this one, do I number in the pink numbers or the green numbers. Hopefully y'all say the pink numbers because I bump into the substituent at carbon 2. So let's redraw that. We numbered it in the pink numbers. Like that. So we identify our substituents. Those are the groups that are coming off of that chain. So another way, if it's easier for you to visualize, what if we just color-coded the chain, the parent chain, in a different color? How does that look? It looks a little different, doesn't it? Now what's coming off of that chain, or that pink chain? We have an ethyl, an ethyl, and a methyl. So we just write those down. We have a methyl, and we have an ethyl, and a second ethyl. We've already numbered it accordingly. So our methyl is at position 2. That ethyl is at position 3. And the last ethyl is at position 4. Now we just have to put this all together, putting the substituents first in the name. But when we put the substituents, they have to be in alphabetical order. And we see that E comes before M. But there's 2 of them. So how do we tackle that problem? Simple. We just say, okay, we have a 3, 4 dash ethyl. But we have to put a prefix. If there's multiple, we need to specify how many there are. There's 2 of them. So we have to put the prefix di. So we have a 3,4-diethyl. So we got that one in the name. Now we have to tack this guy on. So we have to do a hyphen because we're adding a number. Methyl. Like that. So we have all the substituents written down in alphabetical order with their locations and all the prefixes that are necessary. Now we just then tack on the parent name at the very end. Hexane. There's a marker also. Needs a little help here, yeah. So that is a 3,4-diethyl 2-methylhexane. Okay. Here's another one. So now these molecules are going to get a little bit more complex, and redrawing them over and over again is just not going to be the best way of doing things. So just pay close attention on how I'm numbering these, and I'm going to use my finger to trace it. So first part, find the parent chain. So 1, 2, 3, 4, 5, 6. Okay, we're at 6. What if I went 1, 2, 3, 4, 5, 6, 7, 8? Okay, so tracing this way, that works. What if I went 1, 2, 3, 4, 5, 6, 7? So from here all the way there to there is 7. But from here to there is 8. What about 1, 2, 3, 4, 5, 6, 7, 8? It's getting the same thing. So I see that there's 2 pathways that have 8. So I know the parent chain right here is going to be octane, because we have 8 carbons. Next thing, we said 1, 2, 3, 4, 5, 6, 7, 8. So that's the longest chain, but how do we number it? Just write it out. So we have 1. So let's get rid of that marker. Let's try this one. Okay, we can number it in that way. All right, and when do we bump into our first substituent here? Well, if this is our parent chain, then that means this methyl and this ethyl are substituents, and we bump into it at carbon 5. You cannot number it and just be content. You have to double check, triple check. What if I number it in the opposite direction? When do I bump into my first substituent in the pink numbers? Carbon 2. So we have to number it in the pink numbers. Okay. So it's the pink numbers, so we could get rid of these green ones. So where's those substituents? We have a methyl at carbon 2. Keep going. We have an ethyl at carbon 4. That's it. Okay, so the correct name would be alphabetical order. E comes before M, so 4-methyl. -2-methyl. And then we tack on the parent name. Now what I want to do now is I want to do some incorrect names with this and see if you can see where the mistake is. Okay, so an easy one would be a misconception that students think that the numbers have to be placed in numeric order. So you could see that in green as an answer choice. That's 100% wrong. Because the rules state that when we name the substituents, they have to be in alphabetical order, not in numeric order. That's something that people will see and do wrong. Another simple, well, not simple, honest mistake would be misnumbering the parent chain. And so that would be numbering it in the other direction, like 1 through 8. So that would mean that the first substituent that we bump into would be at carbon 5, right? So the answer, another incorrect answer would be 5-ethyl, 7-methyl, octane. Another incorrect answer, right? But another one that's like really, it stinks when it happens to you, is when you number the incorrect parent chain and you think you found the longest chain, but you didn't. And so, for example, let's erase these numbers here, because we're getting a little messy here. What if you numbered it this way? Let's see. 1, 2, 3, 4, 5, 6, 7. So you're like, yeah, 7 carbons. And you're like, okay, there's my parent chain, and then I have this as my substituent. And you're like, hey, that's an isobutyl. So you would just go, hey, that's at position 3. 3 isobutyl heptane. If that was, in fact, the longest parent chain, that would be correct, but it's not. It's an octane. And that's another incorrect answer. Got to look at all the different scenarios and double check and triple check yourselves. Another type of problem that you need to be able to do is looking at the name and coming up with what the structure looks like. So the way I like to tackle these types of problems is I first identify the parent name. And that says hexane, that means 6. So I just draw 6. 2, 3, 4, 5, 6. Just in the horizontal linear fashion. That's all I do. And then I see, hey, I have one substituent, and it says it's a methyl. And so where's that coming off of? Carbon 2. So if I number it, I can number it this way. And that carbon 2, so the methyl goes there. That is 100% okay. That is correct. What if I numbered it this way? 1, 2, 4, 5, 6. And then I would have put the methyl there, like that. Made that bond a little too long. They're the same thing. That's our 2-methylhexane. So let's look at some other examples that get a little bit more complicated. Okay, a 2,2,3 trimethylbutane. Find the parent, that's bute, so that means 4. If I number that, 1, 2, 3, 4, pretty easy. We see that we have a total of 3 methyls, but 2 of them are on carbon 2, and then 1 of them is on carbon 3. And then I just double check to make sure that the longest carbon chain is still just 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I didn't mess anything up. And so there it is. There's our 2,2,3 trimethylbutane. Okay, now let's get into like a little bit more of a hairy one. Okay. Okay, this one has a complex looking substituent in it. So how do we tackle this one? The same way that we did with the previous simpler looking ones. Parent name, heptane. Okay. So I'm just going to draw 7. 2, 3, 4, 5, 6, 7. Okay. Then if I number it, 1, 2, 3, 5, 6, 7. It says, hey, we have a methyl at carbon 2. Okay, so there's my methyl. I'll just write it out so we can distinguish that. And then it says at position 3, I have what? A methyl ethyl. So coming off of this carbon here, I have something. Now we have to remember how this nomenclature works here. So we have to understand that if we have just a parent chain, and here's our parent chain, and we have a substituent coming off of it, I'm looking at this part right here. Ethyl tells me whatever's coming off of that parent chain, okay, that has to be carbon 1, that has to be carbon 2. That longest chain in that substituent is 2 carbons long. That's what the ethyl is telling me. And then it's telling me that at position 1, right there, we have a methyl. So that looks like a isopropyl group right there. So what we have coming off at carbon 3 is a isopropyl group. Okay? Now, double check, because adding these groups here may change your longest carbon chain. So let's see if it messed me up or if it worked out. So I'm double checking. The longest carbon chain has to be 7. So we already see 1 through 7 there, but could we number it in a different way? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So nothing has changed with the length. So that's good. 1, 2, 3, 4, 5, 6, 7. And I'm paranoid. Like I gotta double and triple check. Okay. I'm still paranoid. I just want to double check and then is the numbering scheme good? Numbering it from this side to that side? Well, no, why not just triple check here? What if I numbered it this way? 1, 2, 3, 4, 5, 6, 7. All right. Would that change the name? Let's think about this one for a second. In these green numbers here, I bump into my first substituent at carbon 2. And in the pink numbers, I bump into my first substituent at carbon 2. That one doesn't change anything. That's going to be the same molecule. So that one all worked out. So if I numbered in the pink numbers, with the pink numbers perspective, that's the isopropyl. And then in the green numbers, that's the isopropyl. And you can see that the isopropyls are both going to be at position 3. That worked out. Let's take a look at this. Mouthful. How would we draw that? Now I'm hoping you see that it doesn't matter how hairy the problem looks like to me, how simple or difficult. It's the same process. Parent name, decane, draw 10 carbons. So 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 carbons, right? Then it says, okay, we have some complex patterns here. So let's tackle this one first. Okay, what is that describing? So let's draw ourselves just a line here representing a parent chain. And it says, what's the longest chain in this substituent? An ethyl. So that means 1, 2. And then it says at position 1, we have 1,1-dimethyl. So we just stick 2 methyls on there. Ah, that looks like a tert-butyl group. So if we number these 1, 2, 3, our tert-butyl group would go right here. Let's making a mess out of it though. There's our tert-butyl group at position 3. Position 3, 1,1-dimethyl ethyl, which is a tert-butyl. Then it says at position 4, so we're looking at carbon 4 right there. What does it want us to draw? A 1,2-dimethyl propyl. What is that? Well, I don't know. I don't know off the top of my head. I just break it down. Propyl, so that's 3. 1, 2, 3. Carbon 1. And then it says at carbon 1 we have a methyl. And then at carbon 2 we have another methyl. There it is. That's what it's called, or that's what it looks like. So I just mimic that. So that's going to be carbon 1, 2, 3. There's the propyl. 1, 2, 3, right? There's our propyl group. And then it says another methyl carbon 1, another methyl and carbon 2. Now those numbers we just get rid of because they can get a little confusing. Because those, we don't care about that. That's just to figure out what the substituent looks like. There it is. And that's the molecule. I think that's pretty cool.